Investigate and explain that when a force is applied to an object but it does not move, it is because another opposing force is being applied by something in the environment so that the forces are balanced. We'll begin by finding the mass of the model Jeep in each of these steel spheres using a digital scale. By itself, the model Jeep weighs 118 grams. With sphere 1, mass number 1, 614 grams. Mass number 2, the Jeep and the mass together, weigh 1,380 grams. And mass number 3, the largest of the steel spheres, together with the Jeep, weighs 2,443 grams. Next, we'll find out the amount of force needed to pull each of those Jeep and mass setups. The model alone requires almost zero force. This scale doesn't even measure the amount of newtons required to move just the model because it's on wheels. That makes work easier. You'll see as we pull it across the table, we're not registering any newtons on this scale. Next, we'll add mass number 1. We'll pull that across the table using the spring scale. And this one does show a little bit of force required. There's more mass on the Jeep this time. So we are using some force to pull the Jeep and the mass across the table. With mass number 1, we're actually measuring about 0.1 newtons. 0.1 newtons of force. Next, we'll move to mass number 2. Add the mass to the Jeep. We'll pull the Jeep and the mass across the table using the spring scale to measure the amount of force needed to move this mass and the Jeep. And you'll see that with mass number 2, we're actually getting about, it's bouncing around a little bit. Let's call that 0.2. And with mass number 3, the largest of the steel spheres, we should get more newtons of force required to move this mass across the table. And it looks like for mass number 3, again, it's bouncing around a little bit. Let's call that 0.4 newtons of force.